All right, so does order matter? Yes, because all the, in other words, look at the people and say, is all the all the outcomes for these people the same or different?
Different.
They have different outcomes, right? One gets Vegas, one gets a $10 gift card. So order matters, yes. So how many people are we picking? No, how many people are we picking? Three. We're choosing three. We're picking 3 of them. How many options for the first spot? Second spot? And last spot? Make sense? There's 112 possible people who could win Vegas. All right. All right. Are you everybody good with this? Because we're going to move on and we're going to add another layer on there. Do you guys want 15 seconds with your neighbor or 30 seconds with your neighbors to kind of lock this in?
What happens when there's like a lot of factorials? Like what if it's not?
We're not doing any factorials. I'm not using factorials at all.
Oh, okay. So we're not going to do this.
The formula part?
The part that we did, like the pants.
Oh, that? When there's a lot of those? You just
Yeah,
multiply them all.
But what if you have
Okay, so
a huge number?
it could be a huge number. Yeah.
So then you just have to literally do it out like that?
Yeah, I mean, it could be a really, you could have like 2 million something, something, something. It's totally possible.
Okay.
Yeah.
But we're not doing it.
Oh, I'm not going to multiply. Yeah, 112 times 111 times 110 is a big number.
Well, but if you just say you weren't picking out.
What's that?
Like say you weren't picking out 3 and you were just doing, like if you say there were categories.
Oh.
Like if it was 100 pants.
Yeah, 100, then it'd be 100 times.
Oh, yeah, okay.
Yeah. Okay. All right, so here is the second thing. What if order doesn't matter? So the first question is, when does order not matter? One of my students said, she thinks of it this way, which made sense. If you pick people and you put them in a certain place, like you got the Vegas trip, you get the dinner, you get the gift card, then that's when order matters. If you just pick people and you're throwing them all into a bin and they're all kind of rolling around in there, then that's when order doesn't matter. So here, 3 chaperones, I'm picking 3 people and they're all just going into this big bin and it doesn't matter where they go. Does that make sense? They're all just chaperones. Order doesn't matter. Does not matter. So here, I have 4 people, Alex, Ross, Laura, Rigo. How many ways can I choose 3 of them to be chaperones? Order doesn't matter. You can think of it like this. Not Alex, those 3, one way. Not Ross, that's another way. Not Laura, not Rigo. 4 ways. Make sense? If order doesn't matter, there's 4 ways of picking 3 people to be chaperones. What if order mattered? What would it be then? Yeah, so it'd be 3 spots, starting with 4 times 3 times 2, 24. Make sense? So how do I get from 24 to 4? Divide by 6. Okay, so the question then is, why am I dividing by 6? Why? So I want you guys to take a minute today to see if you can figure out, why am I dividing by 6? Why 6? All right, does anybody have an idea? Any ideas at all? Oh, all I'll say is color is important in this picture.
Yeah.
Did you have an idea?
6.
Why 6?
Because we divided by 4 people. 24 divided by 4.
Oh, no. But the question is, why, to get from 24 to 4, I have to divide by 6. Why am I dividing by 6 and not dividing by 8? Yeah.
The number of combinations.
Kind of. It's the number of somethings. The number of...
Orders.
What was that?
Number of the orders they're in.
Yeah. You guys are along the right. So take a look at this group right here. The red group. Who's in the red group?
Alex, Ross, and Rigo.
Alex, Ross, Rigo. If order matters, Alex, Ross, Rigo is different than Alex, Rigo, Ross. It is different than Rigo, Ross, Alex. Everybody agree? But if order doesn't matter, they're all the same group. They're just one. Doesn't matter what order they're in. It's just you three, done. So if order matters, they count as 6. If order doesn't matter, they only count as 1. Does that make sense, everybody? These guys would just, whoops. These guys would all count as the same one. These guys would all count as the same one. These guys would all count as the same one. So if order doesn't matter, I just have 4 groups. So, kind of makes sense? So why are there 6 in this group? Because what? It's because it's the number of ways of arranging 6 people. How many ways can you, 3 people. How many ways can you arrange 3 people? How many options for the first spot? 3. How many options for the second spot? 2. How many options for the third spot? 1. 3 times 2 times 1, 6. So it's the number of ways of arranging these 3 people. That's how many people are going to be in this group. So that's what you have to divide by to figure out how many groups you are. Because combination is all about how many groups there are, not about how many other things. So there's 4 groups. So kind of think about like in a sense, you have to divide out the duplicates. These are all duplicates of each other, if you're talking about if order doesn't matter. So here's the basic line. If order matters, it's 4p3. If order doesn't matter, I'm going to take my 4p3 and divide by 3 factorial. Because I'm going to have 3 spots. So whatever number of spots I'm picking, how many ways can I arrange? I'm picking 3 things. How many ways can I arrange 3 items? I have to divide that out. So combinations has this extra layer. Permutations, straight up, simple, easy. Combinations, you have, when order doesn't matter, you have to add an extra step. One of my students calls it chaos. And I'll talk about that in just a second. So if order doesn't matter, divide by the number of ways to arrange or arrange our items. So in this case it's 3, right? I'm picking 3 items. How many ways can I arrange 3 items? 3 factorial. So again, I would say I would cross out. I don't like these. I think they confuse people more than they help. But what her point was, if order doesn't matter, then it's kind of chaotic, right? It's chaos. So you do NCR, which is just NPR divided by R factorial. So you have to divide out the number of ways of arranging those 3 items. Good, I'll give you an example. So yeah, don't pay attention to that one either, it's confusing. And here's a flyer. This is good. This is an example. So an advertising exec has to pick 3 photos. She has 10 to pick from. Order doesn't matter because they're all just going into the flyer. So how many items is she selecting? Is she choosing? 3. So 3 slots, right? And how many options for the first spot, or for one spot? 10. Next spot? Next spot? But then since order doesn't matter, just divide out the duplicates. Divide by, there's 3 items, 3 times 2 times 1. Done. And it's clean and easy. For every number you have up here, you have a number down here. So there's 4, if there's 3 of them, 3 times 2 times 1. If there are 4 of them, you divide by 4 times 3 times 2 times 1. Good? Unfortunately, all of my examples have 3, and it's not always 3 times 2 times 1. It's however many you have up here, despite my lack of variety in my examples. All right, so you guys do problems 6, 8, and 9. You know, let's change this to be, that's all right. Let's change this to be 4 tickets drawn. Third and fourth is $10. We'll do it like that. That way it's not, they're not all so boring, consistent. All right, so do problem 6, 8, 9. So how many, so you're making a choice for each one. So how many choices am I making? I'm picking exterior color. What else am I picking? Exterior color, what else? Yep. And then transmission, and then engine. Make sense? So making 5 decisions. So you're going to have 5 of these guys. 1, 2, 3, 4, 5. What about the what? Yeah, that's the transmission. So how many exterior colors? How many are there? 7. How about interior colors? How about interior styles? How about transmission? Manual or automatic? 2. How about the engine? 2. Everybody on board? Multiply those. Club has 12 members. President, VP, treasurer, secretary. When you're picking them, are they each going to a particular place? Here, your president, your vice president, your secretary, treasurer, or are they all going in some giant bin and they're all rolling around, it doesn't matter where they go? Specific place. There's a difference whether you're president or whether you're secretary. So, order matters. How many spots how many things am I picking? 4. I'm picking 4, so 4 spots. How many options for my first spot? 12. 12 members. Everybody on board with that? Next spot? Next one? Next one? Good? And then we'll take a look at the last one. And you guys had, oops. We're changing it, right? 4 winning tickets. Did you guys all catch that? 4 winning tickets. 4th place is $10. So, does order matter in the first one? Yes. So it's $100 and $10. Does order matter in the second one? No. I'll get $80. So the first one, how many people are there? 200. And how many are you choosing or picking? P4. How about the second one? 200. Does order matter? No. So it's going to be a C4. Chaos, right? They're all going to kind of run around, doesn't matter where. Okay. So, you guys want another minute?
Yeah.
Okay, take another minute.
Yeah.
Is this the lecture study guide exams? Anybody got one?
Just do that.
Okay. Oh, I need to go over it.
There's 4.
All right, let's go over these. So this one, I'm picking 4 of them. So I'm going to have 4 slots. How many options for the first slot? 200. Next slot? Next one? Last one? Perfect. Here, order doesn't matter. So I'm still going to do the first part normally. 4 spots. 200 times 199 times 198 times 197 but it's chaos. I gotta add an extra step. Divide by, how many slots do I have up here? 4. So 4, 3, 2, 1. Done. Divide by 4 times 3 times 2 times 1. All good? Your calculator can do that. Will be really big. All right. Have a good couple days. We'll see you on Thursday.